Okay, welcome back to the 310 notes. And I want to do some practice problems here of some things that you may see that will help with the homework and will help with the worksheet that you have for derivatives of inverse functions. And what I want to talk about here is what it's asking. Okay, we have a function g, okay, and we have a function g inverse, okay, the inverse of g. And we want to calculate the derivative of the inverse at when x equals 2 on the inverse. So now, when x equals 2 here, okay, x equals 2, that means that y is equal to 2 on my function, okay? And so what I want to do is I want to calculate the derivative of my function to help me find the derivative on my inverse, okay? So what I can do here is I'm going to set 2 equal to x to the fifth plus 3x minus 2. Okay, and we've got to solve for x. So let's talk here for just a second. It's kind of hard to solve this explicitly for x. You probably need to use a calculator to do this. But you can kind of just think about it for a minute, and if you try out a few x values, like let's just try x equals 1, and let's see if that makes this equation true. So I get 2 is equal to 1 to the fifth plus 3 times 1 minus 2. So you get 2 is equal to 1 plus 3, which is 4 minus 2. So 4 minus 2 gives you 2, and this is a true statement. So x does equal 1 on my function. Okay, so on my function, I have the point g of 1 is equal to 2. Okay, and that's kind of what this point is right here. All right, so if I wanted to calculate the derivative, okay, if I wanted to find g prime of 1, okay, then that's just going to be, let's first find our function or derivative, g prime of x is equal to 4x to the fifth, 5x to the fourth. Okay, that's going to be 5x to the fourth, and then plus 3. Okay, and if I find g of 1, I just plug in 1, and I get 5 times 1 to the fourth, which is just 5 plus 3, so you get 8. Okay, so now basically what I have here is, that's what I have here. All right, looking at that picture, I'm finding the derivative of my function at that x value. Now what I want to answer is this part, okay? Find the derivative of my inverse at x equals 2. Okay, so if I find g inverse prime at 2, oh dear, having some issues with the technology. If I find g inverse prime at 2, then that's just going to be the reciprocal of my slope there. So it's just going to be 1/8. Okay, and that's what I get there. But I'm just following this picture here. Okay, I'm not doing anything other than following that picture. Okay. Okay, now let's take a look at question number 3, and that's let f of x equal this function x to the fifth plus x. And it wants to find the value of the derivative on my inverse at x equals 2. Okay, I'm going to use the same concept of my picture here. So what I want you to see here is that x equals 2, that's, on this point on my inverse, okay, that's the x value. That means that y is equal to 2 on my function. Okay, I'm going to use red. Okay, that means that y is equal to 2. So we need to find what x is. So if I set 2 equal to x to the fifth plus x, again, this is kind of hard to solve algebraically, but if you just think about it, if I plug in 1 for x, then I get a true statement. So I get 2 is equal to 1 plus 1, which gives me 2 is equal to 2, so that works. Okay, so x is equal to 2. All right, I'm sorry, x is equal to 1. So what I have here is I have the point, f of 1 is equal to 2. All right, and on my inverse, that means that f inverse of 2 is equal to 1. Okay, so what I want to do is I want to find the derivative of my function f All right, and I really want to find f prime of 1. So let me find f prime of x first. Let me find my derivative. And that's going to give me 5x to the 4th plus 1. Okay, so if I found f prime of 1, okay, then I get 1 to the 5th plus 1. So I get f prime, I'm sorry, it's not right. Got to use my derivative. I'm going to get 5 times 1 to the 4th plus 1. And so that's going to end up giving me f prime of 1 is equal to 5 times 1 is 5 plus 1 is just 6. Okay, so you just get positive 6. All right. So then that means that f inverse prime, I'll write that up here, over here. Okay, f inverse prime of 2 is going to be equal to 1/6, the reciprocal of that. So my answer here would be D. Okay. Okay, let's take a look at number 5. And this is saying that if f of 4 is equal to 5 and f prime of 4 is equal to 2/3, then what's the derivative of my inverse at x equals 5? Okay, so what I'm going to do is I'm going to use the same picture here, okay, that I've been using, and I'm going to write that this is the point, okay, f of 4 equals 5. I have the point on my function is 4, 5. Okay, the point on my derivative is the point 5, 4. Okay, and that's what this information is, and that's what this information is. Okay, so now we know that the derivative of my function evaluated at 4 is 2/3. So I know that f prime of 4 is equal to 2/3. Then that means that the derivative of my inverse evaluated at 5 is going to be, and you guessed it, folks, it's just going to be 3/2. Okay, the reciprocal of that, so it's D. Okay, and so again, you know, I'm just thinking of my picture here, all right, and the picture just kind of tells me what to do, all right. I have a point on my graph, that's my AB point, okay. I know the slope at that point. And then if I switch my x and y value, okay, and look at my inverse function, the inverse evaluated at my value b, which is the y value, okay, of my function, is the reciprocal of what we had here. Okay, so hopefully you're starting to see the pattern here. And let's go ahead and take a look at number 9. Okay. I'm going to go ahead and use the same picture that I had. I'm going to use this anytime that I have a question like this about the derivatives of the inverse. I'm going to use this picture right here. Okay, on question 9, you're given a table of values, and you have this, all these different columns with all these different numbers. And if you know what these numbers mean, it's a little bit easier to answer the question. So I'm going to talk about that for a second. This column here is labeled x, okay? These are the x values, so x values of 1, 2, 3, and 4. This column is the y values on my function f, okay? These are the y values on my function f prime, the derivative, okay? These are the y values on a function g, and these are the y values on the derivative of g. Okay, so we're given this function h, which denotes the inverse of my function f, okay? It's asking us to find the slope of the tangent line when x is equal to 3 on my inverse function of h, which is the inverse of f, okay? So what I want to do is I want to talk about the point on the graph. What is h of 3? Okay, let's just think about the point, okay? And so 3... this is the y value on f, okay? So if I know that, I'm going to look at my column for my function values, and I see that this is the y value here, Okay, so if I wanted to find the x value that gives me a y value of 3, I come over here and look at this, and this is 2. So what I'm going to write here is that I have the point f of 2 is equal to 3, okay? And that's kind of denoting my point right here, okay? And it wants me to find h prime of 3, but the first thing I want to do is find f prime of 2. Okay, if I find f prime of 2, then that's this number here, which is 1, okay? If I have my function, if I have my derivative of f and I plug in 2, I get 1, okay? So as a result, and this one's kind of pretty simple, this helps me figure out what my derivative of h prime is at 3. And it's the reciprocal of 1, which is just going to also be 1 over 1, which is just 1, okay? So that one's pretty simple, but I'm just using the table of values. But I'm also, guys, I'm really using this picture here, okay? So the idea is that we draw this picture every time, and then it helps us answer these questions. And the answer on this one is E. So hope you enjoyed this video. The next video will pertain to derivatives of inverse trig functions. I had a wonderful time.